Okay, I didn't quite get through with the problems I wanted to review in class. So I wanted to just look at those problems. We had gotten through rational equations, and I was just getting started with the chapter 8 problems. So I'll look at those with you here. All right, so number 24 and number 25 are ones where you're trying to simplify a root. One of them's a cube root, the other one's a square root. Okay. All right, so if you had to do one like number 24, it's a square root. So what you might think is how 45 is 9 times 5, 2 3s and a 5. 9 is a perfect square. You know, that pair of 3s indicates that that's a perfect square. These numbers on the exponents are small enough where you can kind of think about what they're saying. There's 5 A's, 3 B's, and 6 C's. So when we're trying to do the square roots, index of 2, we're looking for pairs. So here's a pair. Square root of 9 is 3. Then here I have 2 pairs of A's. So we'll have an A to the second out here. Oops, sorry. I'll get back to my problem. And then there's 1A that's not paired up. There's a 5 that's not paired up as well. So those are going to be inside. We have a pair of B's, just one pair. So we can bring out a B, but there's a B that's going to be left inside. But then with the C's, there's 3 pairs. So I'm going to have C to the third out here. So your final answer should be that. 3A squared B, C to the third, and then the square root of 5AB. Okay. You don't really usually show the index when it's a square root. It would just look like that. Okay. All right, now when it's a cube root, when you break this down, 27 is a perfect cube. It's really 3 3s. Then you have 5 n's sitting there. But this time you're trying to do a cube root, so you need a group of 3 things. So when you do this, out in front of the cube root symbol, you're going to be able to bring out a 3, 1 3, and 1 n. And then underneath will be a 2 and the other 2 n's. Okay, so your answer is going to be 3n, make sure it's cube root of 2n squared. Okay, so just chapter 8 was all about radical expressions and equations. All right. Now let me see. All right, then you might be asked to add or subtract, or to multiply radicals. So let's just look at one adding. This is more recent material, so it doesn't take quite as much to review it. You just want to look at your test and make sure you understand all the problems on your test, and look at the study guide. Make sure you can do all the types of problems on the study guide. All right, so 26 is adding and subtracting. 27 is multiplying. Okay. All right, so when you're adding and subtracting, you need like radicals. All the radicals look different right now, so you're going to work on splitting these up and seeing if they really are like radicals and it's just camouflaged. So when you divide 2 into 72, it goes 36 times. Okay, you can do that a bunch. So you finally get that 72 is 3 2s and 2 3s. Okay. And then 8 is just 3 2s, right? So your first term is fully simplified. Your second term is actually going to be a 6 on the outside with a 2 left underneath. And then the last term is going to be minus 3 times 2 on the outside, and 2 underneath. So we have 6 square root of 2 plus another 6 square root of 2, and it happens to be minus a 6 square root of 2. So we wind up with 6 square root of 2, and we're done. Okay. All right, on 27, we're multiplying these, and they're binomials. So here you're taking 6 square root of 7 times 8 square root of 7, and then you're distributing to the 10 square root of 5. Okay. Then you're going to come back and do this to both. All right. And what we talked about is when you're multiplying, the stuff that's in front of the radical gets multiplied together, so that'd be 48, and the stuff that's underneath the radical gets multiplied back together underneath it. So the first two would be 48 square root of 49. Then here we would get plus 60 square root of 35. I'm going to need more room. I'm going to move that over a little bit. So the first two would be 48 square root of 49. Then the outside two would be plus 60 square root of 35. Then plus 16 square root of 35. And then plus 20 square root of 25. Okay. And some of you have done a lot of the square root of 7 times square root of 7 stuff, and you realize square root of 7 times itself, ultimately it turns out to be just 7. Then these are like terms. They both have a square root of 35, so I can combine those and get 76, but it stays square root of 35. And then there at the end, that's 20 times 5. All right, 48 times 7 would be something. Should be able to do that. So that'd be 240 plus 56. So what is that, 296? No, that's not right. It's 3 something, sorry. I'm brain dead right now. All right, let me just double check that. 48 times 7. 336. Okay, and then here we have 100 at the end. So we wind up with 436 plus 76 square root of 35. All right, let me just double check myself. So 48 square root of 49, 60 square root of 35, 16 square root of 35, and 20 square root of 25. Those are like terms. Yep. And then those can't go together anymore. So that would be my final answer. Okay. All right. Then another thing you had to do . Remember the problems where you had to rationalize the denominators? Okay. So the next two I'm going to look at are the ones where sometimes you have a radical in the denominator, like 28 or 29. If it's just got the one term down there, you're going to just multiply by, if it's square root, you need to rationalize the denominator. You need to get rid of the, it'll say something like that. It'll say either divide or rationalize the denominator. Then what we need to do is multiply by the square root of 3. All right, you can't do this. Some of you did this. But see, that's not mathematically valid. You can't take a number like 7 and just decide to square it. You're going to wind up getting something bigger. It's not equivalent to what you had. So it's not just squaring top and bottom. That's not valid. It's multiplying the top and bottom by the same thing. See, then that's really equal to 1, so I have not changed the original problem. And my answer would be 5 square root of 3 over the square root of 9. So it'd be 5 square root of 3 over 3. And 5 and 3, this 5 and this 3 don't have anything in common, so that's fully simplified. All All right, and then with 29, there are two terms in the denominator. So multiplying by the square root of 2 is not good enough. I'm going to do 7 plus the square root of 2. And I'm going to do that top and bottom. Okay, and the reason I did it is watch what happens in this denominator. I would get 49 plus 7 square root of 2. Then I'd get minus 7 square root of 2 minus square root of 4. On the top, it's okay to distribute. I usually don't until, if there's not a radical on that 5, I just leave it like that. So what I wind up with in the denominator, C, is 49 minus 2, really. I get a 47. And on top, I can check, but 5 and 47 don't have anything in common. So it's okay to leave your answer that way, or you can leave it like this. Okay, either way, that's fully simplified. And either of these could be correct. So on a multiple choice test, you need to be able to recognize if your answer is correct, but just not the one on the choices, you have to recognize that it's equivalent. Okay? All right, so that's rationalizing. And then we did some solving. That was the next part of the test. So like you might have something like the square root of x plus 7 plus 5 equals x, or like 31. Square root of 2t plus 7 equals some number. All right, just like with that square root method we did last class, you need to have the radical by itself before you undo it, before you square both sides. Okay? So if it's square root, I'm going to look at 31 first. To undo that, I would square. And if I do that to one side, I need to do that to the other. So I'd get 2t plus 7 equals positive 4, because that's negative 2 times itself. So when I go in and I subtract 7 from both sides and divide by 2, I wind up getting t equals negative 3/2. But radical equations have to be checked, because sometimes the answer you get is that you think is an answer is an extraneous solution. It doesn't work in the original. Squaring both sides is the problem. You get an equation that's not quite equivalent to what you had. So you have to check. Must check these. Must check. Let me just write it out. You must check. All right. So I'm going to put in the negative 3/2 and see if I get a negative 2. So 2 would cancel. I'd get negative 3 plus 7, which is 4. And the principal square root of 4 is positive 2, not negative 2. So that was my only possible answer, and it didn't work. So this one has no solution. Okay, empty set. Okay. All right, now over here, the mistake that you made if you missed this one normally had to do with you squaring right off the bat. But you got to wait until your square root part is by itself. So I'm going to subtract the 5 first. Then I can square both sides. All right, and then if you got that far and made a mistake, it was normally because when you square, hold on, I think it's thinking right now. Okay, when you square x minus 5, it's x minus 5 twice. You don't just get x squared plus 25 or minus 25. You get minus 5x minus another 5x plus 25. So you get x squared minus 10x plus 25. Over here, the square and the square root, you did it because you get rid of the radical. Now, if that had been a cube root, you would have cubed both sides. Okay? Square root, you square both sides. All right, I see a squared, so I'm going to subtract x and 7, and I'd get x squared minus 11x plus 18 equals 0. I'm doing that getting a 0 on one side because it was a squared. So I know I'm trying to get it ready to factor. So let's see, that would be minus 9 minus 2, x minus 9, x minus 2. So I get both 9 and 2. All right, and then I have to check those. So I'm going to go back to the original problem and I'm going to check whether 9 works, plugging it in where the x is. Kind of. So it's square root of 9 plus 7, then add 5 and see if indeed you get 9. Then check putting a 2 in. Oops, I keep making that longer than I should. Put a 2 in where x is, add 7. Finish that, add 5, and see if you get 2. All right, so this is where the x was. All right, so this one turns out to be square root of 16 plus 5, which is 4 plus 5, which does equal 9. So this guy for sure is good. The 2 could work also, but it doesn't. I get square root of 9 plus 5, which is 3 plus 5, which does not equal 2. So that one has to be ruled out. This 9 is your only answer on that one. Okay. All right, just 2 more little questions I wanted to do. And then you should be doing all the questions on the study guide or working through the questions on the study guide. Okay. All right, on 32, I'm asking you to convert to radical form and then simplify. So convert to radical form and simplify. And then on 33, I'm asking you to write the expression using rational exponents. Okay. So when you're looking at this one's kind of hard because of the minus. First thing I would do is I would think of that as 1 over 27 to the 4/3. Okay. Then I would think, okay, here's where my radical comes in. The bottom number tells me the index. 27 is what the exponent's being applied to, so it's underneath the radical. Then I could raise it to the 4th power there, but then that number's huge before I have to do the cube root. If I do it this way, I can do it without a calculator. And both ways would have been correct when you switch it to radical form. All right, and then that means I do the cube root of 27, which is 3, and then turn around and raise that to the 4th power. So it'd be 1 over 81. So you really have to think on these about what the negative is saying. So this negative meant to do 1 over, okay, because it's part of the exponent. All right, and then what if I gave you the radical and it looked like this, and I wanted to know what it would be with exponents? Well, that 10 is just sitting there out in front. Then the x is the base. The index is 7, so that's the denominator, and then the 3 would be the numerator. And so it would just be 10x raised to the 3/7 power. The 10 is not in parentheses or anything, though. The 3/7 is only being applied to the x. And that would be your answer. Okay. All right, so I just wanted to finish up what I was trying to get done in class. So hope that helps. We don't have class on Tuesday. I'll see you Thursday for the final exam.